Hello and welcome to looking at doing normal probability constants? Why did I say that? Hello and welcome to looking at doing normal probability distribution calculations using Minitab Express. So you'll notice that on the left, Minitab Express, this is its default settings, is like really busy for what we're going to be doing. So I'm going to turn off the navigator. And I'm also going to turn off the data on the bottom part, so I'm going to put it to output only. This is simply because all I'm doing is calculating normal probability, so I have no data. I don't need it. So this first question we're going to look at, and the only question we're going to look at with multiple parts, is looking at speeding vehicles on the I-10 with a mean of 71 miles per hour and a standard deviation of 8. The first question we are going to look at is whether or not, well, people are going over the speed limit. So if the speed limit is currently 65, we want to figure out which, no, this isn't over the speed limit. Wow, I spoke wrong. We want to see which proportion of vehicles is actually traveling under the speed limit. Wow, I feel like my mic is really close. Okay. So we're actually interested in the probability that the speed is less than or equal to 65 miles per hour. Now I just said less than or equal to, but didn't write the equal to portion. And that's because, remember, with a continuous distribution, including one single value, the equal to portion, isn't going to change your probability at all, because that's one value versus something that's, well, infinite, honestly. So whether or not you include that one extra number doesn't really matter here. And it's specifically because when you're doing probability, you're talking about area. And the area above a single point, a single value, like x equals 65, is a line. Lines don't have area. They have no thickness. So it doesn't make sense to make sure that you include that. You don't have to at all. So this is the same with a continuous distribution like the normal distribution as asking, hey, what's the probability that I am going less than 65 miles per hour? And since I'm lazy, I'm just going to write the less than, because going through all the symbol nonsense drives me crazy. Anyway, so how we do this on Minitab Express might be different from what you're expecting. In Minitab 18, you would use graphs, but we're going to use graphs. It's just they're under the statistics tab. So hit statistics, and we're going to go over to distribution plot, and we're going to use display probability. This is the only one we will be using for today. There are other ways to do this. This is the easiest one in my mind. All right, so notice this defaults to the standard normal distribution, aka the normal distribution with mean 0 and standard deviation 1. I don't have a standard normal, though. I have one with a mean of 71 and a standard deviation of 8. This also defaults to, hey, what would you like to specify, the probability or the x value? Well, since we know the x value, that's what I want to specify, and I want Minitab to give me the probability. So I'm going to change this to a specified x value. And then I need to choose, is it right, left, equal tails, or a middle? And in this case, I'm looking at values. So think of x, the unknown number, or all the numbers that are less than 65. So if you picture the number line with 65 on it, the numbers that are less than 65 lie to the left of 65. So I want a left tail. And we're going to put 65 in there and go ahead and hit OK. And there she's at. Okay, so when you read this graph, the first thing I always check is my mean correct and is my standard deviation correct with what was looking at the problem? Because if those are incorrect, sorry about that, then, well, you can't go forward, so done. And the other thing is this will always mark where the mean is on your distribution. That's kind of nice. And the value you asked it for. So since we asked for stuff less than 65, there's 65 for us. And just like with the binomial and the geometric, it's shaded for you the area that you're interested in. That red section is your probability. So, and just above it will be the value of that area. So it turns out this happens 22.66 or sorry, 0.266 or 22.66% of the time. So, you know, about 22%-ish of people, rounding terribly, go under the speed limit. I think my grandpa does this. Either way. Who goes under the speed limit? It's just crazy pants times. Anyway. So, we're going to look at B, and that's going to be what proportion of vehicles travel between 50 and 70 miles per hour. If you have a hard time reading these compound inequalities like this, you can always start by reading just part of it. So this is saying that, oh, I want all the speeds that are bigger than 50, and then read the other half, and they have to be smaller than 70. So if you're thinking about it that way, it's like, oh, the stuff bigger than 50 and smaller than 70, it's the stuff between the two of them. Good times. It's always an and, by the way. So let's look at doing an in-between. So we're going to go back to distribution plot, display probability. This is one thing I get annoyed with about Minitab Express is you have to type it in every time, unless you tell it you want to alter what you've done previously, but I don't want to do that because I want all of my graphs at the end. I'll show you how to look at all of them too. Let's see, I know x's, so I got to change this to specified x. And here I have two values, and I want values in between, aka things in the middle of those two. So I want to choose middle, and I want to put 50 and then 70. The big tip I would give you for using middles is that you really need to make sure that you put the smaller value first in x1. Otherwise, it yells at you and won't let you do it. Fun times. Go ahead and hit OK, and that is our answer. So almost half. Ooh, too many 4s. I'm going to round this. Good times. Cool. So let's see, what proportion of vehicles will be going more than 80 miles per hour, aka the people that are going to pass you like you're standing still. Let's see, more than 80. I stopped writing mile per hour. I don't know if that's a big deal or not, depending on who you are. Ooh, minus sign. Okay, typing is not my strong suit today. So if I want things that are bigger than 80, so that's stuff on the number line, if you picture where 80 is on the number line, things that are bigger than 80 lie to the right of 80. This is going to be a right tail. So far we've done a left, a middle, and now we're going to do a right. So we're going to go back to distribution plot, display probability. We're still on the normal. Don't forget to put in your correct mean. And, ooh, come on, standard deviation. I'm specifying an x value again, and I want things to the right, which is the default of 80. So once again, make sure you put in your mean and standard deviation, place yourself on x value since that's what you know. You're always giving the computer what you know and asking it to return what you don't know. And then make sure your x value is 80. We're good. And when you look at this picture, it's worthwhile to ask, does this make sense with what I was looking for? Yeah, 80 and the stuff bigger than 80. Okay, 0.13, so just a little bit bigger than 13%. I'm rounding to 4 decimal places because I think that's what I asked you to do in your assignment. I really need to work on my memory. Alrighty, so I'm hoping you look at D and E and notice they're different from A, B, and C. So in D, they're like, hey, researcher wants to know what value makes up the middle 80% of all speeds. What range of speeds is this? Be careful. This is not the same as calculate the range of a data set. This is a range of speeds for the middle 80%. And then E is, hey, the new speed limit will be initiated, and they only want 10% of vehicles to be over the speed limit, aka only 10% of people get tickets. And they ask, hey, what speed limit should meet these criteria? So these are both given percentages, aka probabilities, not x values. So if you write out what this looks like as a probability statement, it would be like, I don't know what this number is, but I want the values in between these numbers. That gives me 80%. So I used question mark and double question mark to indicate that these are not the same thing. So like this one is an unknown value, unknown value. So unknown speed, the middle of them gives me 80. There are a couple different ways you can do this one. The important thing to keep in mind as you look at this is if the middle percentage is 80, so if you're looking at this distribution here, it's the stuff in the center. That means leftover in the tails, like over here and over here from 80%, would be 20%, since the total area under the curve must be 1 or 100%. And so we know the tails will have 20% in them left over. The other thing you can use is the fact that since the normal distribution is symmetric, both of those tails have to be equal in size, which means you can take that 20% and divide it in between the two of them and get 10% each, which is where what I'm going to use to do this next part. So distribution plot, display probability, change her up to that 70, ooh, not 10, what am I doing? 71 and 8. 81, standard deviation 81, can you imagine? So spread. And now, yes, we do have a probability that we know. And the big thing here is I know it's a middle, central 80% of speeds, but when you look at this picture, be very careful. Little p1 is the stuff to the left of the area that you're interested in, the red stuff, and little p2 will be the probability that's to the right of it. And since I want both of my tails to have 10% in them, an equal amount to make it so it's the equal amount in the middle, I want 10 and 10. Because that together makes 20%. So again, this is the stuff to the left of my 80%. There would be 10% of it, and stuff to the right of my 80%, which would be 10% of it. Together all make 100%. And the big thing is since we always know the normal is symmetric, those two have to be equal in size. That's the only reason why you can just divide by 2. With any other distribution that isn't symmetric, you cannot do that, so don't try it. Let's hit OK. We don't do any other distributions, but just for fun math facts, there you go. Cool. So here's how I would write this, and this might not be what you expected. Speeds between 60.75, and, ooh, that was weird, 81.25 miles per hour make up the middle 80% of all speeds on the I-10. This is really specific, but it says exactly what this tells you, which is what I like about the specific answer. So, you know exactly what's going on. At least that's the idea. And it describes the fact that it's in between. It's not a greater than, it's not a less than, it's between these two. I probably should have put miles per hour there too, but whatever. Alrighty, let's get it. Last but not leastly, we want to make it so that only 10% of people are going over the speed limit. So when you're looking at the distribution, you ask yourself, where does that 10% go? Well, it's got to be the 10% of vehicles going over the speed limit, so the upper 10%. So I want to do the upper 10% of all speeds. So if you're thinking about this, you're like, hey, what's the value so that when I'm bigger than it, I get 10%? So if you're picturing, oh, this is going to look like a right tail, you're totally correct. So let's go to our distribution plot, display probability, throw in our 81, 71, oof, I would have gotten that wrong for sure, and our 8, and then it's a right tail, and this is at 5%, I want to make it 10. And then we'll hit OK, and there we are. And you shouldn't be too surprised by this value based on what you've seen in the previous problem. The new speed limit should be, and this is funny, 81.25. The day they start doing decimals for miles per hour in your speeds is the day I'm going to stop driving. Most people would look at this and be like, okay, we should round this to something easy to remember, like 80. And if you round it down, so like you're like, hey, I want to round it down to 80 because that's a more easy to remember number or easy to write on signs, that's going to actually give you more than 10% of people getting tickets. But hey, maybe you want more tickets because, then you make more money if you're the law. Good times. That's all I have for you for today. Peace out.